Hey, hello class. Today we're discussing the equipment of the Rydberg constant experiment. The experiment itself does not require a lot of equipment, but I wanted to discuss it with you guys. So if you take a look at this, the setup consists of three main parts. You have your spectrum tube power supply, and then you have your spectrum tubes. So these are basically tubes with gas in it. Right now I have the hydrogen in there, and so how this works is the power supply sends an electric discharge through this tube with the hydrogen gas and excites it, producing these colors. Okay, so you see this light variety of colors. Now these are more than one wavelength, and so when we look at now this equipment, now this apparatus, we move on to the next thing, which is guy, if you want to look at it. So if we look at here, this is our telescope, this is our grating, this is our collimator, this is our slit that we can change the aperture, the opening. So I can change how far it goes through to see the light, and then I can change here how big the opening of the slit is. Okay, so what do we want to do to find the Rydberg constant? We want to find the locations at which different wavelengths, at which we can see the different wavelengths. So from the last video I talked about different light, when different light enters through the diffraction grating, different light has different wavelength, and so they will diffract at different angles, and finding those different angles will allow us to find the different wavelength colors. The colors at those angles will tell us at which different at which color those angles will tell us the location of the different wavelengths. In finding so, we locate the different energy states of hydrogen, and with using the Rydberg equation I talked about in the theory video, we can get a measurement. So the first things first. So the experiment, you first set up the spectrum tube, the gas tube inside this power supply. You then move on to the alignment of the apparatus itself. And if you look at here, we have two scales, which is one is the vernier, and then the other one is the degrees. Okay, so we calibrate this and we make the readings from left to right, and by looking through the telescope you try to find the locations at which you see the different colors of light that are being emitted by the gas tube. We can repeat this for several elements. So we have deuterium, helium, and neon. So each different element has its own energy states, so it will depend. So again, look at hydrogen. Now look at what happens with, let me take the hydrogen away. I'm using this towel because I don't want to damage light bulb with the oil in my hands. And so let me put neon in there. And so now let's turn it on. Now you get this bright orange. Same principle applies. You want to find the locations at which you see the different light wavelength. The locations at which different light diffracts. And you make those measurements of the angles, you record those The first time you see, as you move this slew to the left or right, you will first begin to see red. Those the first colors at different locations. That is what you consider to be the first order. If you keep moving, then you will see, hopefully with the right conditions, you see the second order diffraction. And if we're at this order diffraction means, I mentioned that in the previous video. This is what the experiment consists of.